Right. Hi, all you cool cats and kittens. It's me, Mrs. Yanez, and I'm going to be going over practice of 14-4. All right, being serious. 14-4, first thing, zoom in so we can see. So here we go.
Ariana counted the different sized bandages in her first aid kit. She made a line plot for the date of the data. Use this data to answer your questions. So right here we have, I'm going to be going back and forth between my screen and your screen. I'm going to replicate, which just means draw, what she is seeing on hers. So at this spot right here, this is going to be 1 1/4. At that spot, there are going to be 2 X's. Then we have this spot right here, which is going to be 1 1/2, 1X. Then we have this spot, which is going to be 1 3/4, and that has 3 X's. The 2 has 4 X's. Nothing until we get over to the 3, and it has 1, 2, 3, 4, 5, 6. So I will show you what I've been doing here. 1, 2, 3, 4, 5, 6. I barely made it. I should have put it down a little bit lower. And this is a 3. All right. So that is the line plot with its correct labels on it. It says, how many bandages did Ariana count? Well, when it's asking about how many and the item or the person, all you have to do is count up the X's. So for me, I just like to put my finger on it or my pen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many bandages did she have? She had 15. So remember, you have to make the box blue in order to type in it. 15 bandages. And if you can remember to do your label, that would be amazing. So this one, what length of bandage does Ariana have the most of? So each X is a bandage. So which one has the most? That would be 3 inch. And I'm going to go ahead and do it fancy because what else do we have to do in our quarantine fun? I'm going to add my full label. What length? She has the most of the 3-inch bandages. All right. Write an equation to show the total length of the bandages if they are placed end to end. So, Mrs. Brooks, when she wrote this out, she already wrote the equation out. So, before we do, we'll just have to get right into it. The first thing you're going to need to do is take 1 1/4 times 2. I'm going to go ahead and just rewrite this so it's on my paper, or my whiteboard in this case, and it's easier for me to solve. And I have it all written out. I'm running out of space. I'm going to have to squish it in, guys. But you're okay with me doing this. All right. So I'll show you what I wrote down, as I had to squish it in real small. I can tell you right now, the easiest part of my problem to solve are these two because there are no fractions involved. 2 times 4 is 8, and 3 times 6 is 18. So I need to add those together. And when I do that, I get 26. Is that right? Yep, 26. So right here, just in this section alone, I have 26. Now I'm going to pretend that's gone so I can focus on some of this other stuff. Actually, I'm going to even grab another whiteboard if I can find it. Yep, right here. Okay. So before you solve anything, you can't start until you get it written as an improper fraction. And if you do that, 4 times 1 is 4. 4 plus 1 is 5. Keep the bottom the same. And when you take your whole number, you put it over a whole. All right, now I'm really good at cross canceling. If you're not, you can go ahead and solve it, but I need to cross cancel right now just because I see that 4 and 2 share the factor of 2. So I can take the 2 out. 2 divided by 2 is 1. 4 divided by 2 is 2. I don't need those anymore. I'm even going to scratch them out as much as possible. 5 times 1 is 5, and 2 on the bottom. As of right now, I'm not going to simplify that anymore. I'm just going to come up here and write that. This one will need to be added to this one, but not yet, because remember, we always do our parentheses first. So I'm going to go over here and I'm going to do this parentheses. So just so you don't get too confused, I have 1 3/4 times 3. I'm going to change it to improper. 4 times 1 is 4. 4 plus 3 is 7. Keep the bottom as the 4. Put your whole number over 1. Check for cross canceling. You cannot do it. Multiply across 21 and 4. So now, I know this is super hard, but you guys stay with me. I am going to go ahead and write 21 over 4 plus 26. And I'm going to write that real big. So right now, as of right now, I have done all of these problems, these top problems. So I'm going to erase them just so I'm not confusing you. Okay. So this is what I've been left with. So they're all adding, and we know with the commutative property of addition, it does not matter where you start with, what numbers you start with. I could do 26 plus 1.5, or I could do this one first. It really doesn't matter. However, I'm kind of liking adding 26 and 1.5 because they both are whole numbers. This doesn't have a fraction to add. So automatically 26 plus 1 is 27. And then I just keep the fraction on the end of it. So I'm done with this part and this part now. And I just have to add these two. Well, there's a problem. The denominators are different. So in order for me to add these up with the correct denominator, I'm going to rewrite them on this other whiteboard. Because really adding and subtracting fractions is best done vertically. So 5 over 2 plus 21 over 4. How can I get a 2 to become a denominator of 4? I can do that by multiplying by 2 on the top and the bottom, and I get 10. I do not have to change this one, so I like to give an arrow over, and that just shows I haven't changed it. Then I add my tops. 10 plus 21 is 31, and my bottom number is 4. This math problem is a lot of work. So now I've done this. This is what I had so far, and now I need to add this to it. Oh my goodness gracious. So 27.5 plus 31 over 4 is my math problem. There's no hole here yet, at least. So there's a few ways that could be done.
I could go ahead and divide and get a whole number and probably a fraction out of this. So if I were to do that, this is what that would look like. I would have to use a 7, that's 28. I could do that. I could definitely turn this into this. That's not a problem at all. And in fact, I think that's kind of what I want to do now. So I'm going, since I divided that, I'm going to go ahead and change it out. That's 7 wholes and a 3/4 left over. This is the longest math problem in the world, I think. Okay, I still am stuck with the same problem of not having the same denominator. So I know I can change 2 into a 4 by timesing it by 2. Keeps the whole number the same. 1 times 2 is 2. 2 times 2 is 4. This doesn't need to change. We're almost done. Add the fractions first. 2 plus 3 is 5 over 4. There's 14. Oh my goodness. There's just one other little step I have to do, and that's regrouping. Because I have this as a mixed number with an improper fraction, and that just does not work. Now, there are a few ways you could do this. You could go like this. And then I always like, when I have the numbers that are just one difference, like 5 is just 1 away from 4, I can always just subtract that 4 from it and add it over to our whole. So I'm taking out a whole because 4 over 4 is a whole, right? 4 over 4 is a whole. It's coming over here. It's being regrouped as 35 and 1/4. Holy bejesus. I don't know if that's a word, but man, that was a hard problem. Whew. Okay, we're going to go with it. We're keeping our answer as 35 and 1/4 space. We'll automatically change it. Okay, I am going to change the color of that. I am going to stop this video for now, and then I will start a new video for the last question.